This node might be able to reach anywhere in the world, which definitely shouldn't be possible. Not because the antenna is magical, but because each node like it forms a mesh network automatically. Now, in my last video, I discovered something called Reticulum, an open source internet protocol that might let you build networks without ISPs. And that video ended up reaching over 2 million people, which I'm sure caught the attention of even my most loyal viewers. There was just one problem. All those tests were between two nodes about this far apart. So yeah, of course it worked. They were basically touching. So naturally, people started wondering, cool, but how far can this actually go? Across a house? Across a neighborhood? Across a city? What about across the entire United States? Because if the tech delivers, we might be able to build an open source internet, one that doesn't depend on ISPs at all. There's just one rule for this video. The data must flow solely through the Reticulum network. So the challenge is simple. Can I be here in Florida and talk to someone in, say, Venezuela, all using Reticulum? Let's find out. Now, I've spent the last few years building what I like to think of as a parallel economy of tech. Basically open source, decentralized, and affordable tech that almost anyone can run. And the whole point is to get rid of subscriptions, gatekeepers, and middlemen, and put the power back into the hands of the people. And if you're watching this, you probably want the same thing I do, which is a network you don't need permission to use. So let's see if we can even get the first brick to hold. We're gonna do 2 nodes, 1 text message, and no ISP. This is the house test. Quick heads up, today's video is sponsored by ClawStage, an open source personal assistant that runs on a Raspberry Pi 5. But more on that later. Okay, so for our first test, we're just gonna see if we can send messages across my house. Very, very modest test, but it'll lay the groundwork for some future, more exotic tests. So let me give you the mental model here. So for the home base node, we have a green Haven node, which is essentially a Raspberry Pi. It's running a fork of open source routing system called OpenWRT. The specific variant is called OpenMANA. And it has traditional Wi-Fi, it has Ethernet, but what makes it special is that it has a sub-GHz, 900 megahertz HaLow chip. HaLow chip and HaLow antenna, or sub-GHz antenna. And so what that lets us do is it bridges all those different Wi-Fi interfaces, but it's able to make a connection at a lot longer of a distance than traditional 2.4 or 5 gigahertz Wi-Fi. So when we send these 2 Reticulum messages, they're going to be going across the HaLow radio. That's why we're going to hopefully be able to get more distance. So Reticulum is actually not running on this router. It's just going to be making use of this router's network, and it's going to be a mesh network. There's technically backhaul that goes out to public internet, but that's actually not fundamental to what we're doing here. So it would be able to function either way. But we're going to be doing a little bit of internet testing here and there, so that's why I want to have that. But so where does Reticulum run then? Well, Reticulum is going to run on the client. So my computer right here is going to be running a program called MeshChat, which is, it's a messenger, but it's also, it runs the RNS service, which is actually like Reticulum itself. This is where we'll send messages, but it makes use of this network. So my computer is going to connect to this guy's regular 2.4 gigahertz Wi-Fi. The network name is green, and you can see I'm connected to it. My computer has no other connections, no Ethernet, nothing like that. So the only way it's able to get a network connection is from this guy's Wi-Fi, and we're connected. We should be good to go. And what we're going to be doing is using the auto interfaces. With Reticulum, you can define interfaces on the actual hardware, like on a USB serial, on a radio itself. It's quite flexible and quite agnostic, but you can also just do this auto interface where if your device has Ethernet or Wi-Fi, it'll just automatically discover that and make use of that, which is nice. And I think just kind of keeps the overhead here pretty minimal. So mental model, base node, base network node, Reticulum client. Now, there's nothing stopping us from, we could add other devices to the setup that also connect to this node here, but you need at least one Reticulum device, and then you need a network for it to make use of. And so that's the setup we have here. Now, for node number 2, because it's something that we're going to be moving with, like on the go, I'm going to use a much smaller device. What we have here is, this is technically the Heltec HDTO1, which is it looks like an MCU. It's not. It's actually a full Linux board. So this also runs OpenWRT. It doesn't run OpenMANA, but it runs OpenWRT, same software as what's running on our Raspberry Pi here. It's not going to have the speed that the Raspberry Pi has because it's a much smaller footprint. But it does have the HaLow radio. It has an Ethernet jack. It has an onboard 2.4 just like this. And it has our SMA connector. So what we can do is we can take another Sub-GHz antenna, same sort of antenna we'd use for Meshtastic, MeshCore, etc., because it's that Sub-GHz. Pop that on here. And this is going to bridge to the HaLow on the Haven. Now, the question is, how do we get Reticulum working on this? Well, we don't need to get Reticulum working on this the same way we didn't put Reticulum on this. This is just going to provide the connection to our network, and then Reticulum is going to run on another client app. The best sort of on-the-move app is an app called Sideband. It's a public APK, meaning you can just download it off the GitHub releases page. You can put it on your Android device. This device is going to connect to this. We're going to use the same sort of auto interface on Sideband. We're not going to do anything fancy there. And this Sideband runs RNS, which is Reticulum, but it also gives you the chat interface. So we'll be able to send messages to our base node here. So I should be able to type on my desktop, receive messages on my Android, type on my Android, receive messages on my desktop. Now, a couple of things about this setup. This setup is not something you've probably seen a whole lot, but there's something that's kind of cool that I've been messing around with, which is this. So put this aside for a sec, but let's just take my iPhone. That Android device is something I use for testing, but my iPhone is something that I use day in and day out. And I actually forgot I had this around my neck. Something that's really interesting that you can do is if I go into my iPhone, and let's turn this down a little bit. So I go into my iPhone and I turn off the network connection. So I'm turning off Wi-Fi, turning off cellular, and I'll turn off Bluetooth, just an AirDrop. So this guy has no network connection, okay? But what's interesting is if I go over to the settings page, what I can do is I can actually plug this guy directly into my router using a USB-C to Ethernet cable. And when I do that, we see Ethernet pop up here as soon as it's plugged in. And I get an IP address and all that good stuff. And what's cool about that is you get internet speeds like this. I actually didn't know that. I didn't know that the smartphones supported Ethernet like that. So are we going to be putting our phone in our home router over Ethernet? Probably not. But what we can do is we can take that same concept and we can actually plug our HaLow board into our phone. And so that's exactly what I'm going to do here. So let me just situate this and turn on my phone here. Okay, so I'm going to just go over to settings. And I'm going to do the same thing. I'm going to turn off Wi-Fi. So Wi-Fi is off. So what we're going to do is we're going to have to turn this guy on. And what we did, just to show you up close here, is that this guy has Ethernet, like that. And we just plug it in like that. And all we have to do now is power this guy up. And I'm going to be using to do that an 18650. And actually, it's the it's similar to what we have inside the Haven. The Haven's actually 21700s, but this is an 18650. And what's interesting about it, it actually has a side USB-C port. Seems weird, but actually very practical. And I actually get a lot of use out of these. So I'm going to plug a USB-C in there. And then I'm also going to, if I can, I'm plugging this dongle in here just so that we can monitor the rate of the power, but it's definitely not needed. So don't get hung up on that. But like, for instance, it will allow us to see the energy draw and things like that. And we see 5 volts, less than a watt of power draw, which is cool. Certainly not going to get those kind of numbers from the Raspberry Pi. So good to get those numbers. So that router board is starting up. And what we're waiting for is for our connection to show up here. And I'm just going to give it a second. It usually takes a second for it to show up. And then on my computer over here, I have mesh chat going. I've already set up some messages with the device, so hopefully I can just keep using that conversation in mesh chat. But let's get this guy connected to this guy's network and see if we can't send some messages, and then we'll go across the house with this, and we should be able to get those messages to go. So one way to know how you're looking in terms of the network is to go to something like Wi-Fi Man. Wi-Fi Man will tell you if you're getting any reads yet. Okay, so we just saw it show up on the mesh. So that's looking good. No IP address, because funny enough, the mesh is actually Batman ADV, which is layer 2. So it's actually working off MAC addresses, not IP addresses. But that's beyond, I think, what's relevant to this video. So now we should get a connection up here. I'm going to go over to settings. Okay, there it goes. Do you see the Ethernet just showed up there? It doesn't give you a whole lot of details because I don't know how many people are using Ethernet on their phone. And we'll talk about, you actually don't need to use Ethernet. I just thought it was neat. This guy could actually use this guy's 2.4 just fine. And that's probably a better way to do it. And then this would just need to be like in your backpack or something. And you could just work off your phone like you normally would. But I just thought the Ethernet part was cool. And we're exploring new ways to do things today. So anyways, so do we know if we have a network connection? So we go back over to Wi-Fi Man. When it says gateway there, that's the HealthTech. And it's got an IP address, 10.410.3. You can see we're on a slightly different subnet than like traditional home network, right? In most cases. But you also see we have an upstream router. So the HealthTech is a mesh node on the mesh gate, which is the Haven. And because the Haven has internet, we can do a speed test and we should get a connection. Let's try just going to a website. Let's go to Amazon and we can see that it does work, but we can see it's crawling. And we can also see that Wi-Fi Man doesn't even register it as a connection. So what's going on there? What's happening is we're using the 1 megahertz channel width for HaLow. That's configurable. But the thing about 1 megahertz is it has the best range, but it has the lowest bandwidth. It actually caps out at, I think it's around 3 megabits per second, but in reality, it's more like 1 or 2. So I think Wi-Fi Man's kind of saying you don't have an internet connection for the most part. But if we change that to like 8 megahertz, you can get as high as like 43 megabits per second, which is more akin to high-speed internet. See if we can't get something. It should be able to. Why is it giving us a hard time with that? Well, you know what we could do? Let's do an internet speed test just on like Google. That should work. Come on, you can do it. Look at that internet speed. But the thing about 1 megahertz is like it's still pretty capable for like IoT stuff. And funny enough, I was actually doing like, I FaceTimed Amelia yesterday using the 1 megahertz channel, and she said the quality was like perfect, which is kind of bizarre. So you can do a lot with a couple megabits per second. I mean, it's orders of magnitude more than like LoRa, and LoRa does text messages, GPS, and stuff like that. So yeah, so it's real internet, right? Where LoRa is just kind of its own protocol. This Wi-Fi HaLow is like true internet. So yeah, those upload speeds are pretty modest, but
You can do a lot with that, and we can always tweak that later. So I wouldn't get too hung up on that. So let's do the Reticulum stuff, right? So we have a mesh. We have two different devices. So on my computer, I'm going to go over to mesh chat because that's what we're going to need. And on my phone, I'm going to go over to sideband. And we're going to see if we can't send a message. So sideband, has runs Reticulum, has all the configurations around that, but also has the actual messenger itself. So if I go to conversations, I see mesh chat. So I'm going to select that, and I'm going to say, "Are you with me?" And it's going to try to discover a path. Well, it already says it was delivered, and I see a dot over here. So actually that was pretty quick. Let's see if we can do something a little bit more here. I'm going to do a voice note. So I'm going to say high quality voice. We're going to do allow while using app. Testing 1, 2, 3, 4. This message is being sent across Reticulum. And then I think you send a note with that. I'm just gonna put voice. Okay, the note came across, but where is voice message? Oh, I didn't click save to message. Okay, let's do it again. Testing. This is a voice message that will be sent across Reticulum. Stop recording. Save to message. Test. Okay, I think that's gonna work here. Sometimes you gotta refresh. Yep, there it is. Testing. This is a voice message that will be sent across Reticulum. Cool, so we just sent a voice message across Reticulum, and then maybe we can do an image real quick. So we're gonna do high-res image, DCIM, camera. All right, and there are our images. It says it was attached. I'm gonna do IMG. Just showing you a little bit kind of what you can do with Reticulum, right? So I just sent a message. It looks like on mesh chat, you kind of have to like navigate away and then navigate back. And there it is, there's our image. So, all right, we're successfully sending messages across Reticulum from client to client. But what's cool is the clients are powered by our Wi-Fi HaLow mesh network, and everything here is basically open source. So pretty impressive what we're doing already. But I recognize antenna number 1 is very close to antenna number 2. So let's go across my house and see if we can't continue to get these messages to send.
Mr. Bruno. Codename Silver Fox. The world needs you, Mr. Bruno. We have a very important mission for you, Mr. Bruno. I know you've been in retirement for several years, Mr. Bruno, but you are the only one who can help us. We need your expertise for one last mission to save the world, Mr. Bruno. Will you help us? Will you help us, Mr. Bruno? Okay, so can we get a message to send through? Let's take a look here. So just go ahead and try something out here. So I'm going to do test 1, 2, 3. And it was immediately delivered. So that's really what we'd be looking for. And then I guess for fun, let's go ahead and take a picture of Bruno. Bruno's going crazy over there, but he's helping us with our mission. I just snapped a little picture of Bruno. So I should be able to come back over to sideband, and then in sideband, should be able to do one of these. We're gonna do high-res image, DCIM, camera, and then it's that, I believe. And we're gonna say Silver Fox, because that is his code name. There it is. Oh my god, look at that shot. Okay, so we are able to send messages across just fine. I can even open up sideband here. We see our picture of Bruno that we sent to mesh chat. And then when I go back up to my office, I should see these messages on the mesh chat. Oh my god, Bruno. So across the house, pretty trivial actually. It seems to be working fine. So what we're going to do is we're going to push this a little bit further, and we're going to try to do messages across my neighborhood, so like several kilometers, and see if this continues to hold. Okay, so now we're back up here, and I'm just taking a quick look at mesh chat. I'm going to refresh it. Okay, and we see that the messages came through. So there Bruno is fighting some imaginary, I don't even know how he contorts like that. But anyways, I don't think people understand just how disruptive this space is going to be over the next couple years with things like Leo from Amazon. Starlink is already a multi-billion-dollar company, and just the advent of AI and LLMs when it comes to coding. I mean, the barrier to entry to this stuff just keeps going down and down and down. And we're here to take advantage of that. Okay, so across the house, we have been able to achieve. The next mission is going to be to send messages across my neighborhood. So in order to make that work, I want to actually upgrade our antenna setup here, because my house is a cement brick. So yes, sub-GHz can penetrate dense material, but we're not exactly giving it kind of the best advantage by permeating the signal from within an enclosed structure like that. So what I want to do is I want to mount an antenna outside my house just so that it is able to go even further. So let's do that. Okay, so like I mentioned before we do the neighborhood test, I want to put an antenna outside my house because, again, house is made out of cement bricks. So if I put the antenna inside, it immediately kind of hits the brick and starts reflecting, and it can penetrate through the brick, but it's not going to be optimal. If we could just get it on the other side of that concrete, I think we're pretty much going to extend the range considerably. So the way I'm going to go about that is, this is a fiberglass outdoor antenna with 9 dBi gain. And this is, I think the center frequency is 915 for this one. I got it on Amazon. I think in retrospect, I probably would have gone with just a reputable antenna supplier, because it's hard to verify if the antenna is actually tuned properly and what the center frequency actually is. And they probably expect most customers not to do that. So I've been getting good results out of this, but I would probably just go with a vendor that has a really good reputation as opposed to just sort of like a generic brand on like Amazon or something like that. But this has been working well, so we can stick with that. Now, I don't immediately want to start drilling holes in my house or the facade or anything like that, because I don't know where I'm going to put the antenna ultimately, and this is really just for an initial test. So what I'm actually going to do is this antenna uses a BNC connection. And so it mounts a particular way. But what I'm thinking is this. I have a kind of windowsill here. And what I think we could do is put a tension mount between the two sides of that. And so this will run, because there's like two pretty solid concrete sides that we can set this up against. And it's a tension mount, so I don't have to drill any holes. And then what I'll do is, once this is up, I can use something like this. This is just an antenna bracket mount. I can use something like this to actually get the antenna on, and it's going to look something like, let me take this off. And we will set that up something like this. And then, now that we have this like that, we'll be able to, if I unscrew this nut real quick, we'll be able to get this fiberglass antenna fixed onto this. So that comes down like that. And then all we have to do is put this nut on. That will secure it in there. Okay, right? So you have something like that. Okay. And then the final piece is this needs to run into the Haven node. So now, because this is a BNC connection and our Haven node is SMA female, we're gonna need to convert those two. And I just have a BNC male to SMA male, which will work with the Haven. So apparently the longer the cable, the more loss you have. So try to keep that cable as sort of short as you can. But I'm not sure what that loss looks like. I'm sure it's not that bad. Okay, so what we'll do is we'll screw in the BNC connection here, right? So that looks like that. And then this guy just goes right into the Haven node on top, and we'll put that right down here. So anyways, that's our mission, and this should allow us to get sort of a temporary antenna on the outside of my house. Okay, so first thing, I do want to grab a chair so that I can actually reach outside the house. So I'm going to put this right here. And then now that I'm going to get up here. Okay. And then we want this to be like that. So just make sure that that is like that. Come back in here. Come back over here. Okay, and then now we need to tension this up. All right, I think we're good for a temporary mount. So the next step is let's get this antenna put in here. And then the final step is gonna be running this guy, running the BNC connector into here. So ideally we have a flat cable. We don't have a flat cable. So this guy's just gonna get squished a little while we have this going, but that's okay. So now we would just have to hook the Haven node up to this. So I'm gonna have to probably put it over here. Let's see if I can reach there. Yeah, I should be able to reach. So before I turn her on, guy comes off. That is SMA female. And hopefully get this guy. It's barely gonna reach. Right on the edge. Okay. Okay, cool. And then plug this guy in. Okay, and because we turned on the Haven node, I should be able to log in over here. I can. Looks like everything is up and running. We don't have any other mesh devices right now because they're powered off. But I should see some information here. Yep, 915 megahertz. And so now the Haven green node is making use of the fiberglass antenna with the 9 dBi that is outside the house. It's still not perfect because it's pretty close to the wall, but should give it a fighting chance once we start moving around the neighborhood. So anyways, we have our antenna set up outside. It is a high gain, high altitude, probably, I don't know, 20 or 30 feet off the ground, which is pretty decent. But to run the neighborhood test, we're gonna have to have a node that is mobile, a node that we can use on the go. And for that, I have something up my sleeve that I wanna show you. Which brings us to today's sponsor. I'm not gonna lie, when this thing arrived at my house, I didn't really know what to expect, but I was pretty sure I was about to experience a real-life episode of Black Mirror. But once I started playing around with it, I was pretty impressed. This little guy is a Kickstarter that brings OpenClaw and Home Assistant to a Raspberry Pi and pairs it with natural language understanding to give you a powerful local agent without buying expensive Mac Minis or sending your chat data to Bezos or Tim Cook. Claw Stage runs on OpenClaw, which, if you haven't heard, recently got acquired by OpenAI for reportedly around $1 billion. So there's definitely interest in this space. But beyond queries, weather, and calendar integrations, OpenClaw has a hub of skills. So I decided to download a Tesla skill to see if I could control my car. OpenClaw guided me through the entire process, including creating a virtual key and provisioning access. Miko, what's the battery on my Tesla right now?
Smog's battery is currently sitting at 53%, which gives you about 119 miles of range. Plenty for now, unless you are planning a spontaneous road trip.
Miko, can you honk the horn on my car?
Consider it done. So if you are anywhere near Smog, you should have just heard him growl.
So that's kind of wild, and yes, I named my car Smog from Lord of the Rings. Miko gets the joke. So now I'm controlling my fantasy dragon car from open source software running on a $65 computer. This timeline is so dumb, and I love it. Anyways, guys, this project is really a great entry point into OpenClaw, and their Kickstarter is kind of going bananas right now, so check it out in the link in the description below. All right, back to the mission.
Okay, so I may have done the unthinkable. Yes, I have put a node on my car with a magnetized antenna like this. And it was actually kind of funny because this week I was washing my car and I kind of forgot that I had this guy on here, and the guy had to take it off. Thankfully, he reminded me. Otherwise, this thing would have ended up probably with a circuit fried on it. So anyways, the way this works is we have a magnetized antenna board here. This is currently running a kind of an experimental antenna. It's a right-hand circularly polarized antenna built for the sub-GHz frequency. Now, we'll mess around with that later. It has certain properties. It doesn't immediately give you like way better range, but it does have some certain interesting properties, particularly if you pair it with an LHCP and do MIMO. Then you can get a lot of new capabilities. But just for this test, we're going to use the standard linearly polarized antennas, because if you're going to use these circular ones, then you want them on both sides. And the one we have on the side of the house is linear. So we're going to stick with linear. So I'm actually going to just unscrew this. And this is just a standard SMA female connector. And so what I can do here is if I reach into my pocket, we're going to go ahead and just use one of these stub antennas. This one actually works pretty well. It's not exotic, but it actually, like when I do the RSSI reads and things like that, it's pretty good. So like you end up with, I don't know, a pretty clean look. You're still running a cable into the trunk, which is probably not ideal, but it gets the job done. And I'll show you what I got going on the inside. So if I just pop this. Okay, so throw the antenna in here. We don't need that right now. So the Tesla has a 12 volt, one of these, right? So I can just pop that in there. But what I then have is just a USB-C. So what I'm thinking is this will power the HealthTech that we got going on. That is going to be our mobile node. And then right here we can just see we have the SMA male connector, which will just go right into the HealthTech. So I guess let me just show you that setup real quick. So really all we do is we don't need the battery on this guy now because we have stationary power here. So I'll just put that to the side. But again, right, we have our this is the same device that we were using upstairs. It is this guy. We'll keep the power read on there because I like to just keep optics around the energy. So, okay, so now we just need to hook up the SMA. And again, this is the one that's magnetized on the hood of the car. So we'll just get this in there like so. If I can get that to work. I like the right angle one because it just doesn't put as much pressure on, or as much strain on it. And then the USB-C will just go into here like so. Yeah, so it's already kicking out power. You can see like the LED going and all that stuff. Okay, so it's already going. Now, okay, in terms of getting this connected to the Reticulum client, like I still have my Android phone here, and we could Ethernet it in like we did last time. And what that would look like is just getting, well, we would just grab this cable here. We would plug that right into the HealthTech, and then we would get the USB-C side, and we would just plug that into the phone like so. See if this works. Okay, we just saw Ethernet come through. So, we should be good there. Let's do a real quick test. Okay, Wi-Fi Man doesn't like that for some reason.
Let's just go to Amazon, see if we can get any internet. Okay, so internet is working. It's slow, but that's what we'd expect. So let's do internet speed test. I think Wi-Fi man just says, oh, it's so slow, it's probably not working, but it actually is working. Okay, so we do have internet. It's just crawling, which is fine. So let me show you guys another thing real quick. The HealthTech actually has a 2.4 gigahertz Wi-Fi network. So if I actually take this out, right, so I just took out internet, Ethernet, but I go back over to network. So we're not at the mercy of that Ethernet. I just thought that was cool. But we can also, if we go to Wi-Fi, so we turn on Wi-Fi, this guy should have a local, see HealthTech naked. I call it naked because it doesn't have any enclosure. So look, we're already connected. And now if we do the same thing, we have internet. So like, you don't have to use the Ethernet. This thing can just be in the car, and that's actually fine. Let's actually just do that. Let's get rid of the Ethernet cable. So this guy's just going to be in the back. I'll be up front connecting over its 2.4, and then the Wi-Fi sub-GHz antenna is what's going to end up doing sort of like the backhaul to our network that actually has the internet. Hopefully that makes sense. Okay, so before going out, I just wanted to validate that we're able to send messages right here, and we are. So let me show you the setup real quick. So again, this guy's connected to the green node upstairs. Connected to the green node upstairs. It's running Reticulum right here in an application called Mesh Chat. And I'm going to say Mesh Chat, and I'm just going to send that across, right? It says it was delivered right away. Cool. This guy is connected to the HealthTech over its 2.4 Wi-Fi. And you can see we just got the message Mesh Chat. So they are talking over Reticulum, and that's what we're looking for at this stage. And the antenna that it's doing that talking over Reticulum is the antenna that's on top of the car, which is what we're looking for. So I can say, hello. It's delivered pretty quickly. Little quirk of Mesh Chat is you have to like go away and then back, but there it is, right? So, okay, so they're talking to each other. I'm going to leave this computer up in my office, and then this one I will just take with me into the passenger seat, and we will see how far we can send messages. And again, these messages are going over HaLow at a 1 megahertz channel width, and yeah, we'll see how it does. Okay, so I'm literally in my driveway. Let's just make sure that we can get a message through. Test 1. Delivered. Okay, so we're still in business. Okay, so we're about 1,000 feet out. Let's see if we can't get another message to go through. Okay, delivered. Delivered at about 1,000 feet, so that's pretty sweet. Okay, just got another message through. You can see test 3, probably at about 1,400, 1,500 feet. And we're gonna keep pushing it here. And yes, I have full self-driving on, so all I have to do is pay attention. All right, looks like we might have hit our limit here. Yeah, just failed. Yeah, we hit a limit at about like 2,000 feet. There's quite a few things you could do to like improve the range and stuff like that, but you're not gonna get like orders of magnitude further range. So I think like you get messages around your neighborhood. That seems doable even with the same setup we had before, like the Wi-Fi HaLow. But how do we actually get messages across a city? That's like a lot more challenging. So anyways, that's our next objective. We got messages reasonably across the neighborhood. So now we're gonna up the ante here and try to get some messages to the neighboring city. And just to reiterate, guys, like the reason we're doing this here is that we have a really cool open source protocol on our hands that's very dynamic, very capable, very flexible. It's called Reticulum. And frankly, there's a lot of interest there, but we're trying to figure out, like, practically speaking, like, what could this actually look like in practice? Could it scale up to something like the internet? I mean, we know that the architecture of the meshing algorithm should be able to support that because it doesn't do repeat flooding, and it stores routes, and it scales linearly and not exponentially. These are all very key things that frankly aren't true of other mesh networking technologies that are out there. Like a lot of those mesh networking technologies kind of they basically stop working once you get past several nodes because the overhead just gets more and more complicated and complex. So technically Reticulum kind of excels in that regard. But, you know, can we spin up this sort of open source internet across the country that could actually go toe to toe with sort of the big ISP, big telco, sort of legacy internet? That's the question. Theoretically, it should be possible, but you know, we want to kind of push it to the limits here on that channel and answer that final question. And then just like, why does this matter? It matters because Reticulum's kind of like the blockchain of communication. No one owns it. It's decentralized. It's community run. It's unstoppable. It's uncensorable. You know, countries can make it illegal. I mean, just like I think in the US, like the smart contract tornado cache, I think to interact with that smart contract, I think is technically illegal. So, you know, they can make legislation, but they can't physically stop you, which is interesting. And they certainly can't impose their agenda on you and kind of limit your action potential in the digital world, which is something that Mark, the founder of Reticulum, the creator of it, kind of emphasized, and rightfully so. So, you know, for me, it's good to see Reticulum kind of getting the attention that I think it deserves, and I also think that you know, this is the next model, the V2 of communications. It's not going to be centralized. Everything's going decentralized, and there's a reason for that. But the powers that be, the incumbents, are going to push back, just like we see with some of the legislation coming across in California around like 3D printers and stuff like that. Solar, 3D printers, cryptocurrency, decentralized mesh networks. These things all threaten the incumbents, but they benefit the people. So, you know, what side of that equation do you want to be on? I think it's interesting and helpful and useful and ultimately good for humanity to put the power back in the hands of the people. I mean, the whole part of one of the founding tenets of America is that government should serve the people, and people shouldn't serve the state, right? And you have checks and balances, and you have decentralized, even within the government, of having different states, right? Like, we don't have to have different states, but we do so that they can kind of govern themselves, and then it kind of bubbles up into, you know, what makes up the entire government of the United States that has worked pretty well for 100 years. So anyways, this kind of just takes that ethos into the technological realm and brings it into the communication space specifically. So the main question I get from people is really just how to get started with all this stuff. So I finally put together a course called the Parallel Primer that walks you through the entire tech stack, the software, the hardware, the radios, the physics, and gets you capable with the technology. We build a node from beginning to end, and we even use some of the most cutting edge AI techniques to move as rapidly as possible. We remove all the fluff and just bake in all the hard-won insights that we've learned over the years. So if you want that, check out the link in the description below. So we were able to get a couple thousand feet, maybe 1,000 or 2,000 feet around my neighborhood. I will say that all the houses in this development are cement brick, so it is pretty dense with obstacles for the signal to have to penetrate, so probably not ideal, but technically we were able to get a signal around the neighborhood. And this is Florida, so there's always something going on with the weather, which honestly just makes this whole project feel a lot more necessary. So for the next test is the city test, and we're basically trying to see if we can get a signal to go from one city to the next. Okay, so usually when I go aerial, I try to use the kite. I like the kite because it's low tech. You can keep it up there for as long as you want, and frankly, it can go really high up. but there's literally no wind today. So we're actually going to use my drone, which should also work. So I decided actually I'm gonna bring my computer with me. So this is Amelia's computer, and this will be our base Reticulum client. It's also running Mesh Chat. It's connected to the green Haven node upstairs, and then the Haven node has the Wi-Fi HaLow antenna that's hanging outside the house. So that's the network that this is on. And it's we already have a conversation going with the Tesla node, so we're able to get messages through here. But now we're going to go several miles out, kind of across the city, and we're going to see if we can't get a message back to our base node right here. So now we're going to run the city test, and I know some of you might be thinking, well, to get data across several miles, like just use ham radio. And I can definitely appreciate that. In fact, there's even a project out there called AREDN, which is Amateur Emergency Radio Disaster Network. And that's basically the idea behind it. But the technology we're using is different than ham radio. So ham radio, first off, you need a license because you're going above the 4-watt EIRP that our technology has to adhere to. But second off, you can't encrypt ham radio. So anyone who intercepts those signals can basically can get in on your conversations. Your conversations are not private. Also, it's analog and it's not full internet. So what we're talking about here is the ISM band, which is unlicensed. It can be encrypted, and it's going to be full internet. We're leveraging the Wi-Fi HaLow protocol, but it's the same band as things like LoRa, Meshtastic, that sort of thing. So I think ham radio has a place, and I'm definitely going to get my license. And I think it would be really cool to make a IP mesh radio that was just like 50 watts or something. But we're at the mercy of keeping this unlicensed, but we also want to keep it secure, and that's what Reticulum really excels with. Everything's like cryptographically complete. It's encrypted by default, so it has all that sort of privacy baked into it. So I have a script here that basically tells you the health and status of your mesh. So right now I am near my house. So you see all 3 devices by MAC address. And that beeping says that there's a good signal. You see an SNR of 73. But this is what we're going to be checking once we kind of go several miles out to see if we can get... Okay, so now we can only see 2 nodes. That's because the gate fell off. We are now where we want to do our range test. We're out kind of in the middle of nowhere. We want to do our range test out here. We're going to pop the drone up, but we only see 2 nodes by MAC address. That's the Tesla node, that's the drone. And we hope that when the drone goes in the air that we get a 3rd node here. That is kind of the hope here, so we shall see. Okay, so this guy is going in the air. Should be pretty intuitive as to what's going on here, right? With the 18650, we have another Heltec mesh node. We have the MusicWorks 915 antenna, and this is going to be able to reach my base node at home. But when this is in the air, I need a way to get sideband onto this network. So that's where the Tesla node comes in. So we'll have a 3-way mesh. Sideband will run Reticulum. So none of these devices run Reticulum. Reticulum's just going to make use of this network. And again, because it's sort of protocol agnostic, it doesn't care that we're running everything over Wi-Fi HaLow or whatever. And you could even do more exotic things with like mixing radios with LoRa and HaLow and traditional Wi-Fi and stuff like that. So yeah, it's a pretty cool setup. And if it all works, sideband on my phone is going to connect to the Tesla node over 2.4. The Tesla node is going to connect to this over Sub-GHz. This is going to connect to my base node over Sub-GHz. My base node is going to connect to my Mesh Chat desktop over 2.4, and we should be able to get a message back to base across the city here. Okay, so we're getting node number 1 set up here, which is the Tesla node. This guy's just going to sit in the car, and then we'll have another node. Let me just get this guy plugged in first. We'll have another node that goes into... Okay, we see this guy booting up. So, okay, so that's the Tesla node. The second node that's actually going to give us the range to be able to reach back to our house, which is about 4 miles away, is going to be actually this guy.
is low. Aircraft will return to the home point in 10 seconds.
Okay, so yesterday we tried to get the signal at about 4 miles using the drone. The drone wasn't going past 100 feet because I needed to update the firmware and I needed to log in. And by the time I did all that and then got it back into the sky, it was dying. It was like low battery. So anyways, we're back. We're going out to our spot today. But as fate would have it, we're having a bit of weather today. So hopefully there's not so much rain that we can't get up there. But what's interesting is there's wind. So I might pivot and try to use the kite instead of the drone to get our node up into the sky. So let's see how it goes. All right, and then, so I want to show you real quick. What we got going on here. All right, so we only got 2 nodes on the mesh right now, kind of as expected. We're hoping when we get the kite into the sky, though, that we end up getting 3. Okay, so you can see our kite is way up there. And what do we have here? We have our 3rd node. So now the question is, can we send a message over Reticulum? Okay, so I spent the last couple days really trying to make the HaLow test work. We put a node in the sky with the kite. I tried all different things. I was able to get a 3-node mesh working. The problem is the kite would see the home base node. It would spot it for like a second, and then it would take like another 10 seconds until it would see it again, which just isn't adequate to actually send data. There's a bunch of things going on, right? Like, when I was in Miami, when I was in Brickell, I would turn on these radios and I kind of took for granted that they would just kind of work. But the difference was I was hundreds of feet in the air in a high-rise apartment. Now I'm here in a kind of normal home and I don't have the same sort of altitude. And yes, we have our antenna right there, but it's still on the side of the house. The house is made out of concrete. It's not above the house. There are other houses like in the vicinity that are kind of blocking the signal. So it's just not as advantageous, like a sort of vantage point, as a lot of the stuff that I was doing when I was in Miami. So anyways, I think what we're going to do, by the way, I think if you did a better setup with Wi-Fi HaLow, you could still get the cross-city test to work, but I just, I don't really have the time right now to get that working. We'll come back to it at some point. But what I'm thinking is, because these antennas are all sub-GHz, like same band as LoRa, I want to pivot to trying LoRa. LoRa works fine with Reticulum. Actually, Reticulum doesn't care what radio you use. And LoRa has a lot of special properties that really make it the king of range. It can operate below the noise floor, which HaLow just can't do. So it can like tease out the data as long as it can identify a pattern, even when there's just tons of noise around it, which is something that, yeah, Wi-Fi HaLow just can't do. So we're going to try LoRa. And also with LoRa, you have a bunch of like kind of levers that you can tweak, like things like coding rate, spreading factor, bandwidth, stuff like that, that you can kind of optimize the signal to go even further. So we can use the same antenna. I just need to set up a bunch of LoRa nodes, which is going to take a second. And then hopefully we can get a message to go across town. Now, the trade-off is we don't get quite as much bandwidth. It's not real internet, but that's fine. We're just trying to send messages over Reticulum. So anyways, we're going to get working on setting up those nodes and seeing if this doesn't solve our problem and seeing if we can't finally send a message across town. So I'm still trying to get these devices to work. So I'm trying to, because I don't have the highest powered devices or even frankly like the latest chips, I'm going to try to get Reticulum provisioned on some of these devices here so that we can try to get this cross-city test working. I've been having a lot of trouble, but I think it all has to do with like my setup because technically it should all work, the physics of LoRa and all that. So anyways, still chugging along here, but putting Reticulum on a couple new devices here to see if we can't improve our range. Okay, so just wanted to give a little update here. So we've switched over to LoRa. I have the RNode running here and it's actually hooked up to our external antenna that's outside the house. It's a high gain omnidirectional antenna. But right now I'm just doing a little like local troubleshooting. We have our other device here. This is another, essentially it's an RNode, a different board. I'm just messing around with different antennas, but I don't think antennas are the issue here. And then 2 mesh chat clients. And I'm just not getting the range that I should. I'm able to get these 2 to talk like it when I go out to the neighborhood, but I should be able to go much, much further. So I'm not 100% sure what's wrong here. I'm starting to look into like the RSSI, which is the signal. And I might recruit some other boards. I do have some newer boards that have higher transmit power. But something, and like we can also configure different things like the coding rate, the spreading factor, what's the other one? Bandwidth, stuff like that. So I'm going to keep tweaking here, but LoRa should be able to go much further. And like with Meshtastic, I've been able to get way more distance. So I'm not 100% sure what's going on here, but I'm going to continue to iterate here until we can get this city test to work. Okay, so I didn't have much luck in my neighborhood. I don't know what it is. I think there, there's a lot of dense cement brick houses and yeah, it's just, it's a lot of cement to try to penetrate. So what I'm gonna do instead is there's a big, long straightaway section in a certain part of my town. I'm gonna try to set up one node on one side, and then I'm gonna drive the car down this straightaway and see how far we can try to get a signal. And there's no major obstructions here. Like there is a bend, so it's not perfect line of sight, but it should be better than the neighborhood, I'm hoping. So we'll see. And then this time, so we have 2 Heltec V4s, which are running 27 dBm. We've changed the parameters so that the bandwidth is 125 kilobytes. The spreading factor is 12, which is the highest. The coding rate is 8. And yeah, I think those are the major things for the parameters. So we're really trying to optimize range here, and we're just sending text messages. So I'm gonna go place the first node, and then we can drive with the second one attached to the car and see if the messages keep coming through. We have a script on the Haven node that's driving one of the Reticulum instances. There's a script that sends a ping every 60 seconds. So as long as we get those pings, we are connected. Okay, so I have it elevated. It's probably about 7 or 8 feet. And I'm on a bit of a sort of berm here, so I'm hoping that I'll be able to get a signal going all the way down there because there's really no major obstructions. So that should help with LoRa not having to penetrate all this cement brick. And then on the car, we just have the Muzi whip, and it's gonna be right on the back of the car like that. Okay, so I'm in the car, and I don't wanna disrupt this too much, but we do have ping 23. So we should continue to get pings, so I'm gonna start driving out. Okay, we are now driving and we just got another ping. RSSI was -44, which I don't think is too bad. And SNR was 5 dB, and that was ping 25. Okay, so we're at about a half a mile, and I just got a ping 26 at about a half a mile. Okay, we just got ping 27 at 1 mile, -85 RSSI, and -3.2 SNR. So we'll see how far we can keep pushing it. So I'm gonna try with the alpha on there, and then I'm also gonna go in a different direction and see if we can't get more distance. Okay, so putting it on a little berm, we were able to get over a mile. The problem is, if I go in one direction, then there's a school between me and between the 2 nodes. If I go in the other direction, then there's a factory between the 2 nodes. Metal always acts as a bit of a Faraday cage, so I'm going to try one more thing. So I'm not going to elevate the node, but there is a straightaway that's basically unobstructed for a long period. I'm gonna try just putting one node on one end and then driving out the other end. And the only potential thing that might be an obstacle is other cars on the road. But anyways, this is the last thing I'm gonna try, so we'll see. All right, finally having some success. So we just got a message at 1.5 miles. RSSI is -92, which is not great. SNR is 3.2, which should be okay for now. And that was ping 67. Okay, we just got 2 miles. Ping 68, SNR is 4 dB, which is pretty good. RSSI is -91, so that's 2 miles with line of sight. Just got another ping at 3.4 miles. So finally having some success. We're at -6.2 SNR, so I'm expecting it to fall out pretty much any time now. It's just interesting, this node isn't even elevated. I mean, it's elevated on a tripod, but it's in a flat. It seems to be a little bit more sensitive to obstruction than needing the elevation. So I don't know, you never know with these things. There's always some element of randomness, but good to finally be getting some success here. Okay, so it seems like it really likes line of sight. We knew this, but I had success in the past with like reflection and urban settings, so I was a little confused. And also elevation didn't seem to help us as much as I thought it would. So just interesting. I'm going to continue to play around with like these antennas and radios and positioning and stuff like that. Ideally, I would have liked to get one on a kite or a drone, because then you can really just like crank it as far as you want. But anyway, so we got 3.5 miles. That dropped out on my way out. Then when I was coming back, reacquired signal at about 3 miles. So I'm pretty happy with that. Is it a true citywide test? I don't know. Depends what city we're talking about. But I think you get the gist there. And if you can get more line of sight, you would get more range as well. So I feel pretty confident about that. So I think the next thing is, how would we get it from one state to another state? Or like how would we get it across the country? I'm here in Florida, and if I wanted to talk to someone in California, could we use Reticulum to do that? That's the question. Okay, so with the LoRa radios, we were able to get 3.5 miles. It wasn't a perfect test, but it was just basically on an open road, so decent test. No elevation, no altitude, and really no exotic setups there. But if we did the math on that, right? If we assumed a 3.5 mile hop using LoRa nodes, distance from here to say even California is 2,500 miles, then we would need 800 nodes to achieve that connection. And although theoretically you could stick a LoRa repeater in the sky, like a CubeSat, to get around the curvature of the Earth, but you'd still probably need multiple satellites to cover a full coast-to-coast path. Or you can do what projects like MeshSat are exploring, which is to use the LoRa mesh, a gateway over USB serial, and then end up connecting to something like an Iridium modem so that one gateway can carry a message for the whole mesh. But again, you need to broker an agreement with Iridium, and you do have to pay for the right to use their infrastructure. Still a cool setup I'll probably explore in the future, but not exactly something I can get up and running with the gear I currently have. At this point, I'm staring at the math and thinking, cool, all I need is 800 nodes, a space program, and a small national budget to get this to work. But then a thought came to me. Because here's the interesting thing about Reticulum. It doesn't actually care what kind of network the data travels across. So, Wi-Fi, Ethernet, tunnels, LoRa, Reticulum doesn't care what the link is. And even something ridiculous like Morse code, theoretically, could work. Basically, if it can move ones and zeros, Reticulum can route it. To Reticulum, they're all just links. So instead of building hundreds of radio nodes across the country, what if we just connect two distant mesh networks together with a tunnel? One here in Florida and one in Venezuela with my editor, Adolfo. But how would we actually do that? So to bridge that gap, we're using something called tailscale. Now, we all know the internet is just a series of tubes. And building on that example, tailscale is basically your own private set of tubes. Tailscale creates what's called a mesh VPN. And that just means that multiple machines can join the same private encrypted network and communicate directly with each other, which, if we set up correctly, could potentially give us all the long haul we would ever need in our network. In fact, I already use a setup like this. So for this YouTube channel, I've struggled for a long time to build a good workflow with my editor, Adolfo, who lives all the way in Venezuela. We've used things like Adobe's Frame.io, we've tried remote storage, cloud tools, etc. Moving hundreds of gigabytes back and forth was
constantly breaking. So I ended up building a NAS in my home lab running an open source OS called TrueNAS based on Linux, and then I installed Tailscale on it. Now, Adolfo just connects to my private tailnet, and through some encrypted VPN tunnels and Samba black magic, the drives show up on his computer as if they were local to him. So when I drop a file onto the NAS here in Florida, it virtually instantly appears on his machine in Venezuela, like it's sitting on his own hard drive. And so far that's been getting the job done without issue. So one of the really cool things about the NAS that we've set up is that I can generate a piece of content like a video, say for instance with my phone. So I just hit record, I'm snapping a video right here. And what I can do is once I have that content ready to go, I can go ahead and airdrop it over to my computer. And that uses Bluetooth, and that should show up in my downloads. So that puts it onto my computer, but my NAS, which is over here, has a bunch of different drives, and my editor, Adolfo, over in Venezuela, has Tailscale. So what's cool about that is if I take the video that I just recorded and I pull it over onto the NAS, he should be able to see that show up on his NAS in real time. And go ahead and play that, Adolfo. I think it's because it's a .mov. Oh, never mind. There we go. Okay, so it took a second there, but so I don't have to do anything. All I have to do is take my files, put them on the NAS, which is right there, and he's able to access and watch and edit all that content from wherever in the world because he just connects to my tailnet. I have Tailscale running on my TrueNAS server, and it really makes our whole editing process a lot faster and a lot more streamlined. So that's just like one example of how you could use mesh VPNs to do some really creative things. So I thought if that works for sending videos, there's no reason it shouldn't work for connecting two disparate mesh networks. Now, to clarify, this is not the public internet. Now, technically the packets are still traveling over existing internet infrastructure, but they're not traveling over the public internet in the way most services do. They're moving inside a private encrypted network. Think of it like a really long encrypted Ethernet cable stretching across the country, or in this case, across the world. All the messages are encrypted and addressed inside Reticulum. So the underlying infrastructure can carry the packets, but it can't read them. And if you don't want to rely on a private service like Tailscale specifically, there are completely open source ways to do the same things using tools like WireGuard or HeadScale, which lets you run the entire coordination layer yourself. But the concept's the same. And what's cool is over time, those links don't actually have to be internet tunnels. We could end up using long-range radio, satellite, or thousands of community nodes. And then it's at that point that the internet becomes optional. So if everything works, a packet should leave my LoRa node here in Florida, hit my computer, travel across the Reticulum network over Tailscale, and appear on a terminal in Venezuela on Adolfo's screen. So let's try it. Okay, so this is where we are stringing everything together, and we're gonna send a message locally from here in Florida, actually all the way to Venezuela. And the current setup that we have is the origin node is a LoRa HealthTech node. So we're sending the message over LoRa. We're using the RNode software. The client is Android, which is running sideband. And that's gonna send the message to my computer, which has another RNode going, but then my computer has another interface that is connected to TCP IP, and that TCP IP is my Tailscale IP address. Adolfo, who is in Venezuela, is also connected to my Tailscale instance, and on his computer, he has a TCP interface listening on my Tailscale IP address. Now, what you're seeing on his screen right now is our chat, but we haven't sent any messages yet. And my goal is to send a message right from here to hop to my RNode on my computer, to hop across an encrypted mesh VPN Tailscale and land in Venezuela, all over Reticulum. So you're gonna find out in real time right now if we can make that happen. So I'm gonna go into sideband here,
and I'm going to go into my messages, and I'm gonna see if I can't send a message. So actually, Adolfo, can you click the button Announce Now? Ooh, anonymous peer, anonymous peer. Anonymous peer. See? Yeah! So that was the message here. All right, so we just sent the message sent from Florida from this Android phone that has no external network via the RNode over this circularly polarized antenna to our RNode over here, which is connected to my computer, which is connected to our Tailnet instance that connected to a mesh VPN, and then tunneled its way all the way to Venezuela to Adolfo's computer on his mesh chat instance, all over Reticulum. So I think I'm confident to say that Reticulum is flexible, it's powerful, and it really can go toe-to-toe with a lot of the latest cutting-edge technology. And it's just really cool that everything's encrypted end-to-end. Sure, it went over the internet, but it went over a private instance of the internet, so it didn't go over the public internet. And the idea here would be over time, we could sort of phase out our reliance on traditional ISPs, but until we're there in terms of infrastructure rollout and having satellites and cell towers and all that stuff, we can still use it to kind of complement the networks that we set up until we're able to be more independent. But yeah, it's just really kind of amazing to be able to get this to work like that, and the possibilities kind of definitely get the wheels turning in my mind about where this technology goes next. But so anyways, we got our message across my house, across the neighborhood, across the city, and now across the world. Part of the path crossed the internet, but not the public internet. It crossed a private encrypted mesh VPN between two nodes, which means we're borrowing the infrastructure, but the network itself is ours. But replace those links with radios, satellites, or community nodes, and suddenly the internet becomes optional. And if we end up going the way a lot of other countries have, having another internet might not be optional. Because a free, decentralized mesh immune from state coercion is going to be pretty valuable in the coming years. And at the end of the day, this channel has always been about two main things, which is communication freedom and running it on hardware that you actually own. And Reticulum might be the most serious answer to both of those things that I've ever tested. And with Reticulum, we don't need permission, we just need a path. So let's make a path. Because there's a reason cyberpunk is having a major comeback right now, and it's that the barrier to entry in this space is just collapsing. Radios are getting cheaper, open source projects are deploying AI to build applications the legacy incumbents would never be able to approve of. Devices get more capable with each passing day, and all of this has me stuck on one idea that I've been turning over for the last several months. A bold idea that will threaten some and inspire others, but nonetheless, an idea I believe whose time has come. Anyways, guys, and as always, thanks for watching. For more, click here.